Hi there, folks. Today we're looking at graphing lines using points. And so, graphing lines using points, the idea here is that there are two options for this. Either doing just an XY chart, coming up with a couple random points that will allow us to graph the line, or coming up with very specific points, and those will be the X and the Y intercepts. So, using a table of values, this is probably one of those methods that you haven't used in a while, because once we learn some of the other ones, students shy away from these guys because there are easier ways to do it. But this will always work. So anytime we have any graph of something, I can always use a table of values. And that's kind of why we've run through this, because we want to make sure that you understand that this is still a valid method, even if we learn other things. So if I just do a table of values, when we do a table of values, we have to make sure the equation is solved for one of the values first, so that I have that input-output kind of scenario. So here it's y equals a negative 2x plus 3. I've got input of x, output of y. And so I just choose values for my input, and I always choose really easy values, something like this. And I just plug them in. And for these guys, hopefully you can do this in your head. Negative 2 times negative 2 is a 4, plus 3 is a 7. Negative 2 times negative 1 is a 2, plus 3 is a 5. Negative 2 times 0 is a 0, plus 3 is a 3. Negative 2 times 1 is a negative 2, plus 3 is a 1. And then negative 2 times 2 is a negative 4, plus 3 is a negative 1. And the other thing is, if you kind of remember how lines work in terms of the pattern here, as soon as you plug a couple of these in, you might notice a pattern to get from one point to the next, and you can stop plugging points in and immediately get the next set of ordered pairs. Okay? But now I plot these. So negative 2, 7. Negative 1, 5. 0, 3. 1, 1. And 2, negative 1. Okay? And here's the thing. The idea here is that I only chose a certain number of x values, but they keep going, which is why I connect this with a line. There are points in between that I didn't choose. Like, I didn't want to plug in a negative 1.5, but I could have. And if I did, I would end up with a value in between here that I could plot. And same thing here. So I have an infinite number of values in between here. The other thing is this kind of pattern keeps going. So as we start to recognize the pattern of the graph, I can keep this thing going pretty easily. And remember, we know that pattern as slope, which we're going to talk about later. Okay? So keep that in mind. Plot a couple points and then graph the line. And the fact of the matter is that I only really truly need 2 points. So I did a whole XY chart with 5 different points. I didn't need all 5 of those. Once I have 2 points, I can continue that pattern because lines follow a constant pattern in terms of rate of change. All right. If I look at the next one, same kind of thing. I'm going to do an XY chart. This one's already in a good format for this because it's y equals. So I have x as the input, y as the output. And I just plug away negative 2, negative 1, 0, 1, and 2. Those are typically the values I always try to start with. And if they don't work out well, then I'll choose other values. And when I look at something like this guy, I can plug in the negative 2. That's negative 2 times 1/2 is a negative 1, minus 1 is a negative 2. Negative 1 times 1/2 is a negative 1/2, minus 1 is a negative 1.5 or 1.5. It's okay to use a decimal here. 0 minus 1 is a negative 1. Let's see, that's going to be a negative 1/2 or negative 0.5. And then this is going to give me a 0. And for this particular example, maybe those weren't the best choices, all right? And if you get stumped on one because there's a fraction, well, skip that value. It would be okay if I didn't bother with this value right here or this value right here. If I only plotted the other ones, I'd still have a decent graph on my hands. I'd still be able to graph this with complete accuracy. So let's see, negative 2, negative 2, 0, negative 1. And 2, 0, that's still enough information. I can still see the pattern that it's creating with those points to get from one point to the next, and I could continue that pattern visually and draw my line. Okay? And again, I technically only need 2 points. I did a couple extra just for good measure, okay, to make sure that that pattern was consistent. All right? And that ensures that I plugged everything in right. If I look at something like this guy, this is not in the format of input-output. I would have to solve this for one of my variables first. And for this particular example, you could absolutely solve for x and then think of y as the input, and then x would be the output. That's weird for a lot of students, but a fun way to do it. Most students prefer to solve for y because we're used to x being the input and y being the output. And see, whichever variable we solve for, that's going to be our output value. Divide by 2. And so we solve this kind of like a literal equation. We're just rearranging the thing. But again, I could have done this the other way. And now I do my xy chart. Again, I just start with a couple values that are easy to plug in. So I plug the -2 in. That gives me a 2 plus 2 is a 4. That gives me a 1 plus 2 is a 3. 2, -1 plus 2 is a 1. And the -2 plus 2 is a 0. And I plot these points, see what it looks like. And again, it should have a consistent pattern to it. If it doesn't have a consistent pattern, it just means that I probably plugged something in wrong and I need to fix it. If I look at this one, yeah, consistent pattern. I'm going down 1 over 1, down 1 over 1. I can continue that visual pattern that I see. But again, I don't need to. As soon as I have 2 points, as long as I'm using a straight edge, I only need 2 points. If I'm doing this freehand, I'm not using a straight edge, so it's beneficial to have some extra points in there to try to make sure my line is straight. Okay? So that's using just any points on the line. So randomly choosing input values, getting output values, and then using whatever points I happen to get to graph this line. The second option for graphing lines using points is to find specific points, all right? And once again, I only need 2 points to graph a line, so I'm going to find 2 specific points, and that's going to be the x and the y intercept, all right? So we have to look at this from 2 perspectives. We have to look at it from a visual perspective, all right? What does the x-intercept look like when I see it on a graph? What does the y-intercept look like when I see it on a graph? But then also from an algebraic perspective, how do I find the x-intercept from an equation? How do I find the y-intercept from an equation? So x-intercept visually, it's where it crosses the x-axis, all right? So where our line is going to cross the x-axis. Remember, the x-axis is the horizontal axis, so it's the value where I touch that axis, okay, where I hit that horizontal number line, all right? Algebraically, I find it by plugging a 0 in for y, all right? I find it when y equals 0. And here's the thing, when you think about that, the relationship between the visual and the algebraic, visually, it's where it crosses the x-axis. Well, y equals 0, this guy right here, that is the equation of the x-axis. So they're really saying the same thing, but from different perspectives, okay? Likewise, the y-intercept is visually where it crosses the y-axis. It's where it touches that vertical number line. And then it exists when x equals 0. I find it by plugging a 0 in for x. All right? And this isn't just true for lines. This is true for any function that we'll ever graph. All right? Any function we ever graph, the x-intercept is where it crosses the x-axis, and we find it by plugging a 0 in for y. Any function that we'll ever graph, the y-intercept is where it crosses the y-axis, and we find it by plugging a 0 in for x. Okay? And once again, the relationship here is the x equals 0, the equation of that line is the y-axis. Okay? So keep that in mind. If I look at something like this guy, from the graph, let's identify the x and the y-intercept. So the x-intercept is where it crosses the x-axis. So it crosses the x-axis right here at this point. And again, let's write it as an ordered pair. A lot of times students will just write x equals this and they'll just write the x value. That is not a good idea. It's better to write it as an ordered pair because it shows us both the visual and the algebraic. Watch this. If I write that down, that point that I just graphed in green as an ordered pair, that's the ordered pair, -3, 0. And so visually, yeah, we can see it. We know where that ordered pair goes. We can see the x value of -3, but we can also see the y value of 0. See, it's visual and algebraic. Visually, it's where it crossed the x-axis, but now I can see that y equals 0. See the y value of 0 right here? Okay, so write it as an ordered pair. It kind of shows us each of those things. Plus, we tend to make mistakes when we just write x equals or y equals. Write it as an ordered pair, and you'll make less mistakes. Okay, especially when we start using these to graph the line, going the other way. The y-intercept, once again, is right here. Let me do it in purple. Where it crosses the y-axis, so visually I can see it down there at -2, but write it as an ordered pair. It's the ordered pair 0, -2. So yeah, I can see the y value is negative 2, but now I can also show that the x value is 0, which goes back to that algebraic definition. Okay? If I look at something like this guy, let's find the x and the y-intercept. So to find the x and y-intercept, to find the x-intercept, I plug a 0 in for y. To find the y-intercept, I plug a 0 in for x. So for this one, let's find the x-intercept. I'm going to plug a 0 in for y. And yeah, I'm going to show all the steps, but I would be shocked if every one of you showed every one of these steps. So I plug the 0 in and I get a 3x equals 12, right? And now I can divide each side by the 3. Some teachers will call the shortcut to this the cover-up method, because students will just go like this. They'll just say, let me cover this up because that's 0. And now they'll solve this in their heads. They'll say, okay, divide by the 3, x equals a 4, and they'll jump right to the answer. Okay? Or they'll jump right to this guy right here. But either way, it's really easy to do, and it's really easy to take some shortcuts here. So keep that in mind. It's okay to cut some corners here as long as you know what you're doing and you're careful and you're plugging those things in and using that little cover-up. Okay? But now I'm going to write it as an ordered pair off to the side. That was a 4 for x, but it resulted from me plugging in a 0 for y. See, it's like I'm doing a mini piece of an xy chart. See, if I think about it off to the side over here, I'm doing an xy chart where I'm plugging a 0 in for x and a 0 in for y. This time I plugged the 0 in for y and I got a 4 out. See, I'm completing that piece of the xy chart. Now I'm going to plug a 0 in for x. And I'm going to solve for y. So once again, that gives me a negative 4y equals 12. I'm going to divide each side by that negative 4. So I get x equals a negative 3. Or sorry, y equals a negative 3. Whoo, that was a close one. How embarrassing. Reading is hard, especially with letters. I mean, whoa, those are complicated. Anywho, I'm going to write that as an ordered pair. That was a 0 for x and a negative 3 for y. So there we go. Okay, 4, 0, 0, negative 3. Okay? And again, it's like I'm completing this xy chart. I plugged a 0 in here, and I got a negative 3 out here. All right? And if you want to use the shortcut, that little cover-up method, you say, oh, if this was a 0, if I kind of blot out that 3x, I can solve that in my head. Divide each side by the negative 4. Y equals a negative 3. Okay? But again, should be very simple and very easy to do. And with those 2 points, I can easily graph this line. For example, if I look at this guy. So once again, let's take some liberties here. I'm going to plug a 0 in for y. Ready? I'm going to cut up a little step. If I plug a 0 in for y, I'm just left with 8x equals 16. Woo-hoo-hoo! Really cutting some corners there, Mr. Jansen. All right, instead of showing the actual 0, I just said, okay, that's 0, that thing's gone. And now I divide each side by the 8. And yeah, most of you could probably solve that one in your heads. Pretty tough. So I get x equals 2. Write it as an ordered pair. That was the ordered pair 2, 0. And now I plug a 0 in for x. If I plug a 0 in for x, I'm just left with a negative 4y equals 16. Once again, taking some shortcuts there. All right, I didn't show the actual 0, but I know that thing's gone if there's a 0 in for x. And now I can divide each side by the negative 4. And once again, most of you can probably solve this in your head. All right, this is fine. But now write it as an ordered pair. 0, negative 4. And now to graph this thing, I just plot those 2 points. Ready? 2, 0. 0, negative 4. And that's enough information to graph. However, unless I'm using a straight edge. If I use a straight edge here, I'm good to go. If I'm not using a straight edge, all right, here's what might happen. All right. I might go like this and go, okay, let me draw this. All right. And I see students do this all the time. There's my line, Mr. Jansen. Yeah, it doesn't look much like a line to me. All right. If you're drawing it freehand, all right, use a couple extra points to make sure this thing is accurate. All right, look at the pattern. To get from one point to the next, I went up 4 and over 2. I could continue that pattern visually to make sure this thing continues on in a straight path. There we go. Now that looks like a line. Okay, so use a couple extra points after you've found the 2 points that we were looking for. All right, if you got a straight edge, you don't need to do that. You can just line it up. Okay. If I look at something like this guy, once again, plug a 0 in for y to find x, plug a 0 in for x to find y. So if I plug a 0 in for y, I'd be left with the negative 1/2 x equals a 6. And now to solve this thing, Some students will say, oh, divide by a -1/2. Ugh, gross. All right. I don't like dividing by fractions. I'd prefer to get rid of fractions by multiplying. Remember, you can always eliminate fractions by multiplying through by the common denominator because a fraction symbol, all right, that fraction bar is a division sign. This is saying divided by -2, all right, instead of thinking of it as times the -1/2. So to get rid of it, I'm going to multiply each side. Okay, so instead of divide by 2, it's times 2, and I do the negative version because I want to get rid of the negative that's there. Okay, remember, a fraction bar is a division sign. You can always eliminate fractions using multiplication. All right, and so what happens over here, I'm left with the x. Over here, I get a -12. If I look at the next one, again, I'm going to plug a 0 in for x this time, so that leaves me with 3y equals 6. I divide each side by the 3, and I get y equals a 2. But now think of these as ordered pairs. I've got -12, 0, and I've got 0, 2. Right? And so as I look at this thing, I plug, let's see, the 0, 2 is easy. That's this. But -12, 0 is way back here somewhere. I can't even see it. All right, it's off my graph. This might be a problem. Well, come back up here. Check out this one for a second. If you look at it, to plot extra points, I used that pattern and said, hey, to get from one to the next, I had to go up 4 and then over 2, up 4 and over 2. But you see that gives us a halfway point that's right here. And so I could do a smaller pattern of up 2 over 1. And so, again, we know that as the idea of slope. Well, you can apply that to this thing because I can reduce that pattern. Or I can, instead of going up 4 over 2, I could go up 8 over 4. I can change the pattern using multiples. Well, up 4 over 2 is the same as up 2 over 1. It gives us the same distance and gets us to the same spots. Apply that here. Think about where that point would be way out here in space somewhere. It would be over 12 up 2. Well, instead, couldn't you go over 6 up 1? So the idea here of over 6 up 1 is kind of going to place us halfway in between those 2 points. Okay? And you could continue that same pattern over 6 up 1. Going in the other direction, okay? Oh, sorry, I've been graphing those in blue. I guess it doesn't matter, but I'm going to cover it up with blue. Oh, man, that was masterfully done, I must say. That was pretty impressive. I can't even see that green line that I tried to use, okay? But plotting those points. The other thing you could do is you could rescale this whole graph and go by 2s or something like that. Make sure you label it if you do that, all right? This guy, a piggy bank contains only dimes and quarters. Graph the function the piggy bank contains $1. All right. So the idea here is that it's giving us the format of an equation where x and y are kind of on the same side. So think about the situation. You know how much a dime is worth, right? A dime is worth 10 cents. So it's 10 cents per dime, and I'm going to call that like maybe d or x or something like that. I'm going to go with x since I'm doing xy. Plus quarters is 0.25. Sorry, 0.25 per quarter, which I'll go with y for the quarters. And I want this whole thing for my piggy bank to equal $1. I'm rolling in it, man. I got $1 in my piggy bank, right? It's all dimes and quarters. Sweet. But see, this is my equation, all right? And this is in a format where it's easy to use points to graph this thing. I can do the x and the y intercepts. I could also do it this way if you don't like the decimals. Think about it in terms of change. It's 10 cents per dime plus 25 cents per quarter equals 100 cents, right? Think about it in terms of pennies instead of in terms of dollars and cents, all right? Makes it a little bit easier. But now from here, I plug a 0 in for y, and now I can solve for x. Divide each side by that 0.1, or you could multiply to get rid of that thing, multiply by 10 on each side. Since it's already in that decimal format, if you want to use a calculator, do it this way. That's fine. Okay? And now the same thing with the, to find y, I plug a 0 in for x. And once again, divide. Or 0.25 is a fraction, would be 1/4, so I can multiply each side by 4. But again, think of these as ordered pairs. This is the ordered pair 10, 0. This is the ordered pair 0, 4. And now let's graph the thing. Ready? 10, 0. And notice I kind of changed my XY chart a little bit to make sure I could fit this. And because really, do we want to graph into the negatives? Can I have negative dimes and negative quarters in my piggy bank and maybe negative dollar amounts? No. So here's what this thing looks like. And now, again, the pattern is down 4 over 10. I could go down 2 over 5 and kind of split the difference, find that halfway point, okay? But it's that pattern recognition for my graph. Wow, that was a pretty ugly line. Just pretend I did better, okay? But notice the difference here is it stops on each end. It doesn't keep going. Don't put arrows on this one because I can't go into the negatives for my dimes or my quarters, okay? And so the last thing I asked here was state the domain and range. Well, because it has to stop on each end, the domain, talking about my dimes, I referred to it as x, so x such that, well, the dimes have to be between what and what? Like, what's the smallest amount of dimes I could have would be 0. The largest amount of dimes I could have would be 10, and it has to be somewhere either equal to those or in between. So it's a compound inequality this time, okay? And then the range, talking about my quarters this time, y such that, well, think about the y values. 0 is the least number I could have. I can't have negative quarters, but the most I could have is 4 because that's what gives me the $1. And it could be any number of dimes in between. And yeah, from a technical perspective, I can't have like 1.1, so maybe I shouldn't have used an inequality on this. So you could make the argument that I shouldn't have even drawn a line here, but all right, we're not going to get into that technical kind of nitty gritty here. Just think of it in terms of what could I have, what would be acceptable here. All right. And yeah, I couldn't have the decimals. So from a technical perspective, I shouldn't write it this way. I should write them as separate values. But again, we want to move more towards that algebraic concept of filling in these gaps. Okay.